Hello everyone, welcome to the next lecture on the PY question series. Today I will continue with the part 2 on the topic number theory. Myself Dr. Harish Garg. You can find me on the YouTube channel. My YouTube channel is Dr. Harish Garg, where you can find the playlist of CSIR UGC NET. In this playlist you can find the various lecture related to the PY question series, and you can see this is the part 1 on the number theory. Apart from them, there are many other lectures available in this playlist. All these lectures are explained with the help of shortcut tricks. Now, what we have discussed in our previous lecture, we have covered the part 1, and in this lecture we have solved the problems related to the congruence, how you can find the last digits, and a very easiest, simplest shortcut tricks related to the Chinese remainder theorem. You must watch about this lecture before watching this today's lecture, because I use again the same shortcut tricks that I explained in the last lecture. I hope you can subscribe my YouTube channel so that when I upload my next video, you will get the notification. Now, I can quickly recall what is the concept about the Euler function. That is all those natural numbers which are less than equal to m, and their GCD is my 1. How you can find the Euler function of any integer n, which is defined by this formula. For example, if you want to find the phi of 15, so your first target is always to write in the prime factorization. So 15 I can written as 3 into 5. How many prime numbers are there? 3 and 5. So I can write 1 minus first prime number, 1 minus second prime number. So if you solve them, you will get 8 is the answer. Similarly, if you want to find the phi of 12, so firstly you are write in the terms of prime factorization. Now, how many prime numbers? Again, there are the 2 prime numbers, 2 and 3. I can write this is 1 over 2, and second prime number is 1 over 3. So I can solve this calculation. You will get the answer is 4 is my answer. Now, based on that, you can find the value of the phi n of any number. Always remember that phi of n is my even number whenever n is greater than or equal to 3, and phi of the prime number, whenever p is my prime, then it is always p minus 1. Also, one more easiest way is phi of n is equal to n over 2 if n is calculated as 2 raised to power k, whenever k is greater than 0. For example, how you can calculate the phi of 8? Since 8 I can written as 2 raised to power 3. So this is of the form 2 raised to power k. So what is the right answer of this? It is my 4. Fine. Otherwise, you can also calculate the phi of 8. I can write this phi of 8 as 2 raised to power cube. Then it is my, how many prime numbers are there? Only one prime number. So I can written this is 2 raised to power 3 over 2. Again, it is my 4. Another concept, that is the number of the positive divisors, which are calculated as k1 plus 1, k2 plus 2, and then so on. You must watch about my previous lectures because I am not covering all those shortcut tricks again. I have already uploaded this video and all the shortcut tricks explained in this part. If you are new to my YouTube video, you can scan and join my WhatsApp group. Now, look at the first question. Let x and y are the values of the remainder when 2 raised to power 100 is divisible by 11. This is my 11 and 2 raised to power 205 is divisible by 11. You can see that this is the same question that I explained you in our last lecture related to the last digit problem. So you can pause this video and you can solve this question. Let me know how many seconds you are needed to get the right answer of this problem. Let me know your answer in the comment box. I will explain you also in this video, but you can solve this and let me know in your comment how many seconds needed to get the answer of this problem. How you can solve that? Since I needed 11, so I got that 2 raised to power 5 is a 32. 32 means that's a minus 1 more 11. Then I need 2 raised to power 100. I can raise to power 20 on the both side because power 20 is my even number. So this is my 11. So this quantity is my 1. Therefore, what is the meaning of that? That is x is my 1 because x is my remainder when you divide by 11. How you can make that 2 raised to power 105? If you multiply both of them, you will get as minus 1. Minus 1 means 10 because I always need as a positive. So this is my 10. Therefore, y is my 10. Now, once you know all these values, what is the first answer? X plus y, 11. 11 is my prime number. So it is 10 is the right answer. X into y, if you multiply them, it's a 10. 10 is not a prime number, so I can break them into 2 into 5. So it will be 2 into 5, 1 minus, there are the two prime numbers, 1 minus 1, it will be 4. So second option cancel, third option correct option. Fourth option, left hand side is phi of 11, right hand side is phi of 1, phi of 10. So what is the phi of 11? 10. Phi of 1 is 1, phi of 10 is 4, which is not equal. So the right answer of this problem is A and C are the right answer of this problem. Okay, look at this another one. I hope you can like and comment on my this video. I hope you can support my effort that I did only for you, that I uploaded on the videos only for you. I'm not running any coaching center. Or moreover, I didn't expect you that you can go to the coaching center and pay a very large amount. Always believe in yourself that you will crack the examination in a very simple manner. Okay, in the group of 265 people, 200s are like singing. So 200, that's a cardinality. Cardinality of the singing is my 200. Cardinality of the dancing is my 110. Cardinality of the painting is my 55. If 60 people are both singing and dancing, and means that's the intersection. Singing and painting is my 30. While 10 are both, all. So that means this is my 10. How many total numbers? 265. That means cardinality of the singing, dancing and painting is my 265. Then your required target is to find the dancing and painting. So that means this is your required target. What come in your mind when you look about these cardinalities? How you can find the A union B union C? The same approach I have used. A union B union C cardinalities, which is equal to A, cardinality of A, plus cardinality of B, plus cardinality of C, minus A intersection B, that is a 60, B intersection C, C intersection A, plus A intersection B intersection C. If you remember that, what is the formula for the A intersection B intersection C? I can convert into the cardinality. So what will happen? This is 265, this is 365, it's a 90 plus 10 is a 80. So it will be the 100, it will be the 20. So X will be my 20 is the right answer of this problem. You can see how many seconds you are needed, or very less second you are needed to crack this question. Let S is the number of the integers from 100 to 119 which are divisible by, okay. Always remember how you can calculate the number of the integers from A to B. First of all, fine. How you can calculate the number of the integers from A to B? That will be always B minus A plus 1. So how many numbers of the integers? That means B is my 999 minus 100 plus 1. So that will be 900. Fine. Then we have to find all those integers which are divisible, neither divisible by 3 and nor by 5. Then the number of the elements of this. I can assume A is my number which are divisible by 3. B are all those numbers which are divisible by 5. Then can you find the cardinality of A? Total numbers are 900 divided by 3. So the cardinality of A will be 300. Similarly, what is the cardinality of B? 900 over 5, 180. I need a intersection B also. A intersection B means all those numbers which are divisible by 15, 3 and 5 both. What is the cardinality of A intersection B? 900 divided by 15. So 15 into, what is the cardinality of, how you can divide 900 into 15? That's a 60. Fine. So then your target is to find neither. That means your target is to find the S complement. That means 900 minus A union B. So what is the 900? What is the A union B? That is a A plus B minus A intersection B. So that will be my 4. that is a 120, that's 420, 900 minus 420, that is A is my right answer of this problem. Let S is the collection of all those integers which are lies in this. So then firstly you can find the number of the integers. It will be 999 minus 1 plus 1, that will be 999. Then all those numbers which are divisible by 3 I call as a, I call as a B. Your target is to S complement. So what is the cardinality of A? 999 divided by 3. Cardinality of B? 999 divided by 37. Similarly, what is the cardinality of A intersection B? 999, 3 and 37. That means 3 into 37, 101. So sorry, 111. Fine. So the cardinality of this is 9. This is my 333. This will be 27. So then can you find the A union B? That is the A plus B minus intersection. So this will be plus 18, 153. Fine. So what will happen? Your target is to find the S complement. So what is the cardinality of this? Total elements are my 999 minus 351. So 48 and then 648. B is my right answer of this problem. Let capital D is a set of all tuples Wi such that Wi is my 1, 2 or 3. The only 3 choices are there such that Wi plus 1 is my even number. That is the only restriction for given to you. Then your target is to find the set of the tuples, cardinality of this. When it will be the even, you have the two cases. First, both are my even number. Fine. Or both are my odd numbers. Because if both are odd, then the sum will be even numbers. So firstly, we can think about the even number. What will be the value of the Wi when both are even? The only possible is my 2, 2, 2. Fine. So that means this is my capital D. The sum will be even. Look about this case. What will happen? What is the choices for the W1? Because your target is to find W1 up to W10. How many choices for the W1? Because I need an odd number. How many odd numbers are there? There are the 2 choices. Similarly, how many choices for the W2? Again, there are the 2 choices. And similarly, for the last case, again, there are the 2 choices. So how many choices for this case? Is a 2 choice. This is a 2 case and 2 case. So total choices for the odd case is 2 raised to power 10. How many choices for the even case? 1 choices. And since they are my disjoint, so the total number will be 1 plus 2 raised to power 10 is the right answer of this problem. I hope you can like and comment on this video. Which of the following statement is my correct? Very simple. Can you solve this? I will give you the 15 second. Can you solve this question? You can pause the video and then solve it. Now, how you can solve this? Look at that. If you read the statement very carefully, every even integer n is greater than 16. You can choose any even number. Let's say n is my 16. Then what will happen? N minus 1, 15 factorial plus 3. Is it divisible? You can see this number is my even number. Fine. 15 factorial is my even number because if you open them, it will be the 15, 14, 13 up to 1. So clearly say because of this even number, the product is even. This is my odd number. So even plus odd and it is my plus sign. This will be my odd. But the left hand side is even. Is it possible that even number divisible by odd number? No. So that is wrong answer. Look at the second option. Every odd number. So you can choose any odd number. So the smallest odd number is 17. So then is it 17 divided by 16? This is my prime number. Fine. So clearly says 16 will be 16, 15, 14. It is not divisible by 17. So this option is also cancelled out. Look at the third option. Every even number. I can choose n is my 16. Fine. Is it divisible by 16 minus 1, 15 factorial? Is it divisible by? So now you can see if I open this bracket, definitely it will be the 2 and 8 will also be there. So it is divisible by 16, but we can't correct the option based on this counter example. Look at the last option firstly. Every number I can choose as a 16. So is it 16 divisible by n factorial plus 1? No, because this number is my even, this number is my odd, sum of this will be my odd, but you can see the right hand side is my even number. So therefore this option is also cancel out. So only left behind is my C is the right answer of this problem. Always remember, start from the first lecture to this lecture, I always tell you the simple idea. You have to read the statement very carefully so that you can discard the option. Your target always to discard the options. Don't forget to like and comment on my video. Let n be the positive integer such that the sum of all those positive integers a which are lies between this and the GCD of is my 1. You know what is that number? That is the definition of the phi of n. Fine. Now the question suggested you the sum of all those positive numbers. So whatever the phi of n, that means your target is say x1, x2 and phi of, these are my total numbers. Then what is the, according to the question, the sum of this, that means sum of the xi, I varies from 1 to phi of n, it is given you as 240 n. Fine. Then your target is to find the value of phi n. Very simple. If you remember my last lecture, I already told you the shortcut trick. What is the shortcut trick is? Whenever you want to find the summation of this quantity, this is always n into phi n over 2. Fine. N into phi n over 2. So if you substitute this value, it will be n phi n over 2, which is 240 n. So can you find the value of the phi n? Phi n will be 480. That is the right answer of this problem. A very simple approach. Moreover, remember that if they are talking about the product, if they are talking about the product of this quantity, then as I told you in my last lecture also, it will be phi n divided by 2. Fine. So this is at June 2014. It may happen that in this coming examination, the product of the exercise are given to you. Okay, let phi n is the cardinality of the set such that which of the following statements are my not true. Fine. Okay, before I start with this question, let me quickly tell you the one most important thing. Look at that. There exists, they are not talking about the for all n. There exists for all n. They are not talking about the for all n. There exists, again they are not talking about the for all n. Fine. How you can solve this problem? First of all, as I told you, phi of n is always an even number. Fine. Whenever n is greater than equal to 3. Second is phi of n is not monotonic. Fine. Not monotonic means that means phi dash may be greater than 0 or phi dash is less than 0 for different values of the n. Fine. Now another trick is whenever there is a question related to the number theory, your first target is always choose n is my prime. Always. And look at the option which is discard and look at the option which is not discard. Fine. So based on these tricks, I can solve this question in a very simple manner. So firstly, I can assume n is my prime number. Fine. Then what is my phi of n? Is n minus 1. Fine. Now look at the option A. Left hand side, phi of n minus 1 Is it greater than of what is the phi of n plus 1? N. Is it true? No, it is not true. Fine. But make sure that based on this, you can't discard the option. Why? Because they are not talking about the for all. They can say there exist. We can find some another n if possible, otherwise not. Look at the second. N minus 1 is less than of n. Yes, it is always true because you can see minus 1 is less than 0, always true. So there exists infinitely. Yes, if I choose n is my prime, so we all know how many primes are there. Primes are my infinitely many. So therefore this option is correct option. But I need a not true. So this option is my true statement. Fine. So that means this option is cancelled out. Now look about the there exists n. Okay, firstly we can think about this because as I told you, if you look about these cases, phi dash is my greater than 0, this case is phi dash is less than 0. Fine. But as I told you, phi is not a monotonic. If it is not monotonic, that means both these statements are my correct. But how you can prove that? If you don't remember that, you can see what is the phi of 2, 1. What is the phi of 3, 2. What is the phi of 4? It is a even 2 raised power, so it's a 2. Fine. Now you can see phi of 5 is a prime number. You can see I need a strictly greater than. If I choose n is 4, it is not satisfied. Phi of 6 is my 2. 5 is, you can see, n and n plus 1. So if I choose n is equal to 5, then clearly say this satisfied. Fine. Now what is a phi of 7? 7 is my prime number. So it is a 6. It is not satisfied. If I choose 8, 8 I can written as a 2 raised power 3. So it will be 4. Clearly says 7 is also satisfied. And is 7 is also satisfied. 6 is greater than of the 4. Now what is a phi of 9? Phi of 9 means 3 raised power 2 into 2 raised to 2 by 3. So that's a 6. Phi of 10. 10 I can written as a 2 into 5, that is my 4. Clearly say 9 is also satisfied. Fine. Phi of 11. Phi of 11 is my prime number, it's a 10. But what is the phi of 12? Phi of 12 is 2 raised to power 2 into 3. So that will be my 6. Again you can see n is 11 satisfied and so on. You can find many numbers. You can see 5, 7, 9, 11 and many more. So that means there are definitely infinitely many numbers which will be satisfied. Now look at the third options. There exists a capital N such that whenever n is greater than 2 and whenever n is like this, phi of capital N is always less than of phi of small n. It means our first target is to check whether the n exists or not. There exists. Fine. It is not for all. I can choose n is 3. What is the phi of n? Phi of n will be my 2. Fine. Then whenever you will choose n is my greater than 3. Fine. Then we all know whenever n is greater than 3, phi of this is my even number. So that means it can be possible as a 2, but we need a strictly less than. That means n is equal to 3 is not possible. If I choose n is equal to 4, what is the n of is my 2? Again, it is not possible. Fine. Because I choose n is greater than 4, that means all are even numbers. If I choose n is equal to 5, then phi of n will be my 4. But whenever n is my greater than of this, I can say phi of, if I choose n is equal to 6, then it will be my 2 and it is not satisfied. Is it possible if I choose n is equal to 6? What is the phi of 6 is? 2. Fine. Then if I choose any number which is greater than of the 6, any number greater than of the 6, phi of n is always greater than of the 2. Why? Because always remember phi of n is my 2 only if n is my 2, sorry, n is my 3, n is 4 and n is 6. While for all other numbers, phi n is always greater than 2. So therefore, I can choose n is equal to 6. Fine. If there exists n, yes, I can choose n is equal to 6, which satisfies this property also. And I can choose all those n which is a greater than of the 6, so that this condition will be satisfied. So that means this is also the correct statement. So both, all these three options are cancelled out. The only remaining is my D is the right answer. That's an interesting question. Fine. Okay, look at this another one. For any integer n, d of n, what is given to you? D of n, number of the positive divisors of the n, number of the prime distinct prime divisors. Okay, what is the meaning of that? If I choose n is my 10, I can return as a prime factorization. Fine. What is the meaning of the dn? Power is 1, power is 1. 1 plus 1, 2. 1 plus 1, 2. So dn will be my 4. What is the definition of the vn? Vn is the number of the distinct prime divisor. How many distinct prime divisors? 2 and 5. That is my 2. What is the w of n? Number of the prime divisors of the n. These are the prime divisors counted with multiplicity. What is the multiplicity? Is 1 plus multiplicity 1. That is my 2. Fine. This is the way, the meaning of this. For example, if I say w of 12, so it will be 12 I can return as 2 raised to power 2 into 3. Fine. So what is the w of n? Multiplicity 2 plus 1 is 3. What is the v of n? If I might take 12, so how many prime numbers? 2 prime numbers. What is the d of n? 2 plus 1, 3. 1 plus 1, 2. That is a 6. That's the meaning of this definition. Fine. They are also talking about the primes. So if you choose any of the primes, say 7, what is the d of prime? Power is my 1. 1 plus 1, 2. V of the prime. How many prime numbers are there? Only 1. W of the prime. What is the multiplicity of this? Power is only 1. And what is the p square? If I take it as a 7 square, what is the w of the 7 square? Multiplicity is only 2. V of 7 square. How many prime numbers are there? Still prime number is my 1. So they are explaining you the meaning of wi's and so on. Fine. Now look at the options. If n is greater than or equal to 1000. So very simple, I think. Okay, again, as I told you, always choose first choice is your prime. Now my target is to choose any number which is greater than of the 1000 as a prime. And I also need as wn is greater than equal to 2. So you can see one option they have given to you as a p square. So can you choose n as a prime number? Any prime number whose square will be greater than of the 1000. So clearly say, first of all, if I simply choose what is the minimum n, if I choose as a 25, then what will be the square is 625, which is not greater than 1000. If I choose 30, 30 square is 900, not greater than of this. 33 square, what is the 33 square? 33 square is 1089. That is a greater than of the 1000. That means n should be near to the 33. But 33 is not a prime number. Then look about the 34. 34 is not a prime number. 35 is not a prime number. 36 is not a prime number. 37 is a prime number. So I can choose n is my 37. Fine. Then what is the w of n? As I told you how you can calculate the wn, that is a multiplicity. Whatever the multiplicities are there. So what is the multiplicity is 2. This is also satisfied. This also satisfied. Then can you calculate the d of n? What is the d of n? N means 2 plus 1. That is the positive divisors. Now you can calculate the log of n. What is the log of n? Log of 37 square. So let me calculate it. 37 square. It is come as 3.13. So clearly say this number is 3. This number is 3.13, which is not satisfied. So first option is cancelled. Fine. These are first method. There is one more method. Apart from thinking about the prime number, you can also think about any two, because n can be the any number. It may be the prime, it may be the composite. but make sure you have to think about any number which is greater than of the 1000. So I can choose as two numbers so that their product will be greater than of the 1000. And since I need also as a log, so the best way is I can choose these two numbers as a multiples of the 100. Fine. If I choose these two numbers as a 100 and 100, fine. Or any prime numbers, choose any two prime numbers which are more than of the 100. Why I choose a prime numbers and 100? Let me tell you. Suppose I can choose 103 or any number. If it is not a prime, then you can choose any two prime numbers. Then what will be my log of n? Since it is my greater than 100, so definitely the log of this quantity will be greater than of the 2, because log of 100 is my 2. Again, this number will be greater than of the 2, so the product must be greater than or equal to 4. Fine. But if you choose both as a prime number, if I choose both as a prime number, what will be the power of this? 1. Then what will be my dn? If both are my 1, then what is my dn? Dn will be my 2 into 2 is 4. But right hand side is greater than equal to 4. Fine. So again, you can see these are my not satisfied. Fine. Okay, look at the second option. Let me clear this. Okay. There exists n such that d of n is greater than of 3 raised power. So if n is prime, there are the two choices. If n is prime, or let me choose n is prime. Then what is my d of n? Is my 2, because the power is 1. Then if I substitute here, 2 is greater than of 3 times root of p. That means p should be less than of 4 over 9. Is it possible? Do you get any prime which is less than of this? No. But remember, they are talking about there exist. Fine. So that means n is not a prime number. Look at that. N is my any composite number. So then I can return this is p raised to power alpha, or I can choose an as a p raised to power k for any k. Fine. Then what is my d of n? It is my k plus 1. So if I substitute in the equation 3 times root of n, does it satisfy? No. For any k, I can choose. If I choose simply k is equal to 2, then 2 plus 1 is 3. Then 3 into some power raised to power 3 by 2. Definitely, this number is not greater than. This number is greater than. So therefore, there exists. It does not exist any number. Okay, look at this third option. For every n, if I choose again n is my p, what is the d of n? Is my 2. What is my w of n? Multiplicity prime is only 1, power is 1, and v of n is 1. Fine. Then can this equation be satisfied? 2 raised to power 1 is less than equal to 1. So for the prime case, it is satisfied. Look at that. When n is any composite number, fine. What is the d of n? K plus 1. What is the w of n? K. What is the v of n? How many primes? 1. So therefore, you can see d of n is k plus 1. Is it a less than or equal to 2 raised to power k? Yes, for any k, because k is my integer. If you choose any integer, it is definitely be less than of this, because the growth of 2 raised to power k is more than of k plus 1. Does it also satisfy 2 raised to power 1? Yes, because 2 is less than of the k plus 1. Definitely said, because k is my integer, that means k must be greater than equal to 1. So this equation satisfied. For all k, it is satisfied. Otherwise, you can skip this option. We will see whether the third option is a right or wrong. Fourth option is a correct or wrong. If wn and wm, what is the w is? Multiplicity 1. Multiplicity same. Can you think about that? This is say my n and this is my m. I choose this is my 1 and 1. So then what is the w of n? 2. I can choose this number as, fine. I can choose both as a prime number, say any number 2, 3, 7, for example. Then clearly say w of n is my 2. W of m is my 2. This equation satisfied. Then what is the n is 6. What is the d of 6 is my 2. What is the m? 7 square. What is the 7 square is? 7 into 6, 42. Both are not equal. So that means your last option is cancelled. The only left behind is, that is my C option. That is the correct answer of this problem. Okay, for the positive integer m and n, which of the following statements are my true numbers? Okay, for all m, so I can choose any pairs. Say m is equal to 1, n is equal to 2. Fine. This case will satisfy m is not equal to 1 and this case. Fine. I will take this example later on. So firstly, GCD of f1, fn, f2. What is f2? 2 raised to power 2, 4. 2 raised to power 4 is 16 plus 1, 17. GM, G1. G1, 2 raised to power 1, 2, 4, 4 minus 1, 3. What is the GCD is? GCD is 1. But this is a one counter example. We can't say this is the correct option. Fn, Fm, Fn, Fn. What is the Fn is? F2, Fm, F of m. M is my 1. So what is the F1? 2, 2 plus 2 raised to power 2, 4, 4 plus 1, 5. 5 and 17, GCD is 1 also satisfied. GM, G2, that is a G1 divides Fn. Is it possible? 3, is it possible 3 divides 17? 3 doesn't divide 17. So third option is, last option is cancelled. Fine. Now I can reverse the values. If I choose m is equal to 2, n is equal to 1. That means now we are thinking about again the first three cases. Then what is my f2, fn? What is the f1 is 5, g of 2. What is the g of 2? 4. 2 raised to power 4 is 16. 16 minus 1, 15. So clearly say the GCD is my not 1. Fn, F1 divides G. So yes, 5 divides 15. So we can't correct the option because this is a one counter example. Now, how you can check about the A and C? Firstly, we can think about the third option. Third option is only F. F is 2 raised to power 2 plus 1. Do you know which number is this? This is called as the Fermat number. Fine. And this Fermat number, if you calculate the F1, F2, F3, they are always be co-prime to each other. They are always be the prime numbers. Once they are the prime numbers, so that means their GCD, Fn, Fm is always 1. So the third option is the correct option. Fine. Now, look at the first option. Whenever m is greater than of the whenever, so I can choose m is my 2, n is my 1, whenever. Fine. Or I can choose m is my 4, n is my 3, or n is my 1. So look at that. Fm divides gm. So what is the gm? Because m is greater than, I can return this number. Since I need as a plus sign, how you can make them a minus b to be the plus sign? I can return this is a square minus b square. So that means this number I can return as a plus b, a minus b. So what will be my a? I can divide it by 2. So that means it will be 2 raised to power m minus 1, 2 raised to power m plus 1. Right? Now since m is greater than 1, again I can break this component into the two parts. It will be 2 raised to power m minus 1, 2 raised to power m plus 1. Fine. Is it okay? Now clearly say what is this number? This number is my fm. Fine. Or fn. Fine. So that means this is a divisible by. So yes, this option is also correct. A and C are the correct options. Okay, for any prime number p, ap is a set of integers such that the power of the p is the prime factorization, then the cardinality. Fine. I think this is a very simple approach. What is the shortcut tricks? How you can find the a of p? That is summation minus 1 raised to power, say, n plus 1, greatest integer of power of k. Fine. Okay, if I use as a k, then here is also I can written as a k, where k varies from 1 to infinity. Now, what is the meaning of that? If you don't remember this formula, again, there is no issue. I will tell you again the shortcut tricks. Look at that, A3. That means your target is a plus minus. So firstly, what is the n? How many numbers are there? 9, 9, 9. Firstly, you divide it by prime. That's a 3. Fine. Minus. So what is the answer is? Greatest integer 3, 3, 3. Minus. If you again divide it by 3, just divide it by whatever the number. 3 plus again divided by 3 and take only the greatest integer. So this comes to be 37. Again plus minus plus, if you divide it by 3, 12. If you divide it by 3, 4. If you divide it by 3, it is my 1 and the rest is 0. Fine. Now we can see whether it's a 250 or not. It is my 222. This is my 25. This is my 3. So it's a 28. If you add them, it is my 250. Yes, this option is correct option. Look at the A5. The number is 999. So you can start the first number divided by 5. If you divide the first number by 5, the first number is 199. Minus again divided by this number as a 5, you will get 3, 9. Again divided by 5, 7, 5, 35. 5, 1 and then rest will be 0. So what is the answer of this? It is my 6, it is my 33 and it is my 199. So that will be 166. Second option is cancelled. Look at the third option. This is A7. 7 is my prime number. Fine. So I can start with the 999 divided by 7. So 142 minus again divided by 7, 70. Sorry, 20. 7 2 are 14, 0. Plus if you divide by 7, 7 2 are 14 minus 0. So it is my, if you subtract them, it is my 122 plus 2. 124 is the correct answer. A11. Divide the 999 by 11. So 9 9 are 99, 0 minus 11 8 are 88 plus 0. The answer is 82. So the correct options are A, C and D are my right answers. If you want to remember this formula, you can do that. Otherwise, just try to write as a division rule. Okay, let A is the integer such that A is my B square plus C square. A cannot be written. A cannot be written as, okay, that means the first option is A cannot be written as P of D square, where D is my integer. I can choose D is equal to 1. Fine. And P is equal to, it's a 1 plus 4k. I can choose any number which satisfied this P. Firstly, you can choose B and C, because B and C can be any number. I can choose B is equal to 3, C is equal to 4. Then what will be my A? A will be my 25. Then can you choose as a D is my 1? Fine. Can it possible that P will be, A will be my 25? Is it possible? Yes, you can see if you choose P is 25, which satisfied this property. So therefore there exists A is equal to 25, D is equal to 1. Sorry, P is equal to 25. If P is 25, that is satisfied this property. Therefore A will be satisfied. So I can written A is 25, which is my one mode of 4. So, but he said cannot. First option is cancel. Look at the second option. I can fix the value of the A and B. Fix the value of the B and C. What is the B and C? 3 and 4. So this number will be my 25. D is my integer. I can choose D is my 1. So then is it possible that P is my 3 modulo of 4? Because I can see 25. So can you written as a 25 is my 3 modulo 4? No, it is not possible. So that means this is my not possible. Fine. So that means this option is the correct option. P, Q and D square, where D is my integer. I can choose D is my 1. Fine. P is my 1 modulo 4. So is it possible? Yes, I can choose P is my 1. And if my P is 1, D is equal to 1. So again, A will be my Q. And Q I needed to be 3 modulo 4, which is not possible by using the option number 2. So this option is also not possible. Similarly, you can see both the P and Q are the 3 modulo is not possible. Right answer is my B, C and D are the correct answer. Okay, let n is the set of all those positive integers. Let an collection of all those 3 pairs such that x raised to power n, y raised to power n and z raised to power n. Z is less than of an. Fn is the cardinality of ans. Which of the following statements are my true? Fn is always finite for n is equal to 3, greater than 3. So firstly find the F3. F3 is the cardinality of A3. I need to firstly find the what is the A3. A3 is the collection of all those elements such that x cube plus y cube plus z cube and z is less than of 3. Fine. Now, can you find the solution of this? We all know by using the Fermat last theorem. What is the Fermat last theorem suggested you? That is xn plus yn is equal to zn has no solution. Fine. For all x, y and z are integers and whenever n is greater than equal to 3. Fine. So that means can you find the value of x, y, z? No. So what is the A3? A3 is my 5. So what is the F3? F3 will be my 0 because F3 that's F3 is a cardinality. Fine. So that means f of n is my 0 for all n greater than equal to 3 because the Fermat's last theorem says it doesn't have any solution whenever n is greater than equal to 3. So Fn is always finite because 0 is a finite. That's the correct option. Now look at the second option. Second option is F2. That means we need to start with the A2. What is the A2 is? X square plus y square is equal to z square. Fine. So yes, it has a solution, but there is one more condition is z is less than of 2 and all these numbers are my integer. That means z will be my 1. Fine. What does it mean? That means z is equal to 1. Do you get a solution? Yes, you can get a cos and sine or 1 by root 2 and 1 by root 2. This is my solution, but this number is not my integer. So can you find any of the integer solution which satisfied this case? Not solution. Therefore, A2 will be my 5. So once A2 will be 5, the cardinality will be 0. So second option is the cancel. Phi of n is 0 for all n. So since we have obtained phi of 3 is my 0 and phi of n is my 0 whenever n is greater than equal to 3, phi of 2 is also 0. The only thing which is left behind is f of 1. So let me firstly check what is the f of 1. What is the a1? That is x plus y is equal to z provided z is less than of 1. Can you get any of the integer which is less than of the 1? No, there is no integer less than of 1. That means your target is to find, is it possible? Is there any integer which satisfied this property? Not satisfied. A1 is also my 5. So once A1 is also 5, F1 is also 0. Fn is a non-zero for some n greater than 2. But we already proved that Fn is always be 0. That means this option is also cancelled. Right options are A and C are my correct answers. I hope you can like and comment on my videos. Kindly support my efforts so that you can learn many shortcut tricks based on the good efforts. Okay, for the positive integer n, phi n is my integer, which of the following statements are true whenever n is greater than of 3. Let's start with the n is equal to 4. Fine. Phi n can never divide 4. What is the phi of 4? It's a 2. Fine. But you can see phi divides by 4. So first option is cancel out. Fine. Phi n divides n. If phi n divides n, so I can choose the same example. That means I can choose n is equal to 4. Then this equation 4x plus 6y is equal to 1 has a solution. So clearly say when, okay, what is the shortcut tricks for you? Whenever you have the system ax plus by is equal to 1, it has a solution only if you find the GCD of a comma b. Fine. Whatever the GCD of a comma b, if it divides the right hand side quantity, then you have the solution. What is the GCD of 4 comma 6? It is 2, but 2 doesn't divides the right hand side. That means this case is not satisfied. Moreover, you can also see about this equation. Can you find the value of the x and y, which are my integers, so that this equation will be satisfied? But make sure these are my positive integers. They are not satisfied. Fine. So therefore, you will get the no solution. Okay. Now, another example you can think about. Can you think about any other example for instead of the n is equal to 4, you can choose n is equal to 6. Why I chosen n is even number? Because we all know phi n is always even number whenever n is greater than equal to 3. So then what is the phi of 6? 6 I can written as 2 into 3. So that will be my 2. So clearly say phi of 2 divided by 6 satisfied. So but first option is again cancelled. If you look over the same example, then n is 6. 6x plus 6y is equal to 1. So clearly say is it possible for the integers? Not possible. Moreover, the GCD of the 6 comma 6 is my 6, which is not divisible by 1. So again, the first and second options are cancelled out. Okay, look at the, firstly, I can think about the last option. For every positive integer k, if k is my any positive integer, I can written this in terms of n raised to power alpha. No, p raised to power alpha. P is my prime numbers. Fine. N is also the prime numbers. I can n is my composite number. Then I can written as q raised to power alpha. Then what is the n into k? P raised to power alpha into q raised to power alpha. What is the phi of nk? Phi of nk is p raised to power alpha. I can choose it as a beta. Fine. This is beta 1 minus 1 over p, 1 minus 1 over q. And clearly say, what is this number? This number is my phi of n. Fine. So p of alpha 1 minus. So clearly say it is divisible by. Fine. Now he said for every, these are my composite numbers. And if and k are my prime numbers and GCD is 1, so then we all know once they are the GCD is 1, they are prime numbers, then phi of n is phi of k. Fine. So clearly say again from this case it is divisible. Now, because it's a part C, so it may happen that the third option is the correct option. Now, n is my greater than 3. This is my, so then it implies phi of n is always my even number. Fine. Then phi of n divided by n. So I can choose is a 2 of m. Phi n is a even number, is a 2 of m. 2 of m is divided by n. Then either 2 divides n or 2 doesn't divides n. It's depending upon you whether you choose n is 4, whether you choose n is 5. Fine. Now, if this happens, what will happen? N is 2m into k for some k, where k is my integers. Then n have at most the two distinct prime divisors. So you can see n is my, where k is my integer. Fine. One prime divisor is my, this is my prime divisor, 2 is my prime divisor. Now look about this case, m into k. M is integer, k is integer. Fine. M is integer, k is integer. Now this product, if it is prime, if, fine, then we get another prime number, then you have the two distinct prime. If it is the composite number, then again I can return this k is my say prime of say alpha, then again you will get the second prime number. So that means you will get as one prime number as a 2, another prime number as a p. P is again a prime number, so at the most you will get the two prime numbers. So yes, this option is also correct option. So C and D are the right answers. Okay, let P is the prime numbers and NP is the number of the pairs of the positive integers satisfying this condition. You can choose any prime number. Say P is equal to 2, then your equation will be x plus y is 1 over 16. Then NP is the number of the pair, that means NP is my cardinality. Then the cardinality is 0. That's wrong. Clearly say if I choose x is my positive integer, y is my positive integer. Fine. Positive. So it will satisfy. First option is cancelled out. Fine. Second way, 4, 5 or 9. So that means you have to solve this equation. The first way is you can think about that the one answer is this. Second, if I choose this number is my 16, y should be 0. No, y should be infinity, but infinity is not a positive number. But how you can solve that? I can simplify this. X 16 times x plus y is equal to xy. Fine. Or I can return this is xy minus 16x minus 16y is equal to 0. I can make them as a factor. It is x minus 16, y minus 16. That means I have added 256 on the both side. Fine. Now both the equations are same. Then you have to find the number of the positive integers. Which things come in your mind when you find the number of the positive integers? That means you have to find the positive divisors. That means you have to find the d of n. Fine. So now you can find that because both are same, your target is to find the value of this number. So I can write this in the prime numbers. It will be my 2 raised to power, it's a 16 square, 2 raised to power 8. So what is the right answer of this? 8 plus 1 is 9 is my right answer of this problem. Read the statement very carefully. They are talking about the number of the positive integers which satisfy this condition. That means you have to talking about the number of the positive divisors which satisfied my this equation. Now this is my equation related to the pairs x and y, and it must be the 216. That means we need to find the number of the positive divisors of 216. So 256. 256 I can written as this quantity. That's the right answer is 9 is the correct option. Okay, look at this another one. For the positive integer n, phi omega of n, number of the prime factors of the n. Prime factor. That means if you're talking about the 6, how many prime factors? 2 into 3, 2 prime factors. Omega of 6 is my 2. 9. 9 is my 3 raised to power 2. That's a number of the counted with multiplicity. Sorry, it's a multiplicity. That means they are talking about the 1 and 1, 2. 9 is 2. If you're talking about the 15, 3 into 5, multiplicity is 2. In this case, omega of 15 is my 2. What is that 12? 2, 4 into 3. So what is the omega of 12 is 2, multiplicity 2 plus 1 is 3. Fine. That's the meaning of this given statement. That is similar to the, which question is the similar one? This one. That is the omega of n. That's the same number of the prime divisors with multiplicity. That's the meaning of the omega n. You can see it's a June 2019 and it is February 2022. Fine. That's why PY question is very, very important to solve before going to the examinations. Then let P is greater than 3 be the prime numbers. Let P is greater than 3 be the prime number. Let's say P is equal to 5. Any prime numbers. And let capital N will be my P, P plus 2, P plus 4. Then omega of N is my greater than or equal to 3. So what is the N? P is my 5, 7, 9. Fine. 5, 7, 9 will be my 3 square. So then what will be my omega of N? It is 1, 1 plus 2. That will be my 4. Fine. The first condition will be satisfied. Equality 3 is not satisfied, or yes, satisfied. There exists a prime P which is greater than 3 such that omega of N is equal to 3. So let me verify this case also. There exists. It is not set for all. How you can verify that whether it's satisfied or not? Now, P is my prime number. What will be my P plus 2? P plus 2 may be prime or product of the prime. Fine. Similarly, P plus 4, it may be the prime or it may be the product of the prime. Fine. So once you know if it is a prime, suppose this is a prime, then if it is a prime, then it will be the Q into, sorry, if it is a prime, then it's Q P into Q. Then P plus Q, if it is a prime or product of prime, then R into S. So definitely this will be 4. If it is a product of prime, then it is a Q into T. Then again it will be the 5. Cardinality will be the 5. So definitely it is not be 3. Fine. Now look about the third option. It is P plus 2. P can never be the smallest prime divisor of the n. P, if I choose P is equal to 5, P can never be the smallest prime divisor of the n. So n, if I choose P is equal to 5, 5, 7, 9. Fine. P5 can never be the smallest prime divisor of the n. What is the smallest prime number in this n? Smallest prime divisor of the n is my 3, which is not equal to P. Fine. It is not equal to P. P can be the smallest prime divisor of n. You can see I choose as a P is 5, and for this case it is cancel. Fine. Now P can be the can never be. How you can prove that? Very simple. You can see if P is my prime, P is prime, then either P plus 2 or P plus 4 is my even number. Is it possible? No, because P is equal to 5, then none of them is even number. But if P plus 2 or P plus 4 is my product of the prime, fine, or a single prime. Clear? So if I choose any of the P, it can never be the smallest prime. So definitely, once you can taken as a product of the prime, you will get a number either as a 2, 3 or anything. Because if I choose 5, let me choose any other number, 7. Then what will be the n? 7, 9, 11. So 9 is again 3 square. 3 will be the smallest prime number. 7 is not. Fine. So whenever you will choose P is prime, then either P plus 2 or P plus 4 is the product of the prime. So that will always be less than of this n. So this option is can never be the right option. A and C are my correct answer of this problem. Okay, given the function n, where n is a positive integer, which are the following statements are my true. All these options are related to the fn. So I can take n as a common, then it is n4 minus 2n square plus 1. This, what is the expression of this? This will be n square minus 1 whole square. So that will be n plus 1, n minus 1 whole square. Fine. Okay. For every positive integer k, there exists a positive integer n such that fn is divisible by 2 raised to power k. Very simple. You can see n, n plus 1 and n minus 1. Look at this, are my consecutive numbers. Once they are consecutive number, that means one of them must be my even. Fine. Fine. One of them must be even. If I choose, if n is my even, if n is even, then n plus 1 and minus 1, they are my odd. Fine. If n plus 1 is my even, then other two are. Then it must be fn is divisible by. So how you can choose that? If I choose n is even, 2 of instead of the k, I can choose as a 2m. What will happen? 2 into m, it will be 2m plus 1, that's the odd number. Fine. And it is 2m minus 1 square. Clear? So clearly say it is a 2 for every integer k. So 2m plus 1, 2m. So it is divisible by 2 raised to power k. Fine. If n is my odd number, 2m plus 1, then it will be 2m plus 1. It is my even number, so it will be 2 times m plus 1. Again, it is my 2 times m of whole square. So you can see 2 into 2, 4, 4 power 2, that is 16. So 2 raised to power 4, 2m plus 1, m plus 1, m square. So in both the cases, we get a 2 raised to power k as a factor. Fn is an even number for every n greater than equal to 20. I think that's not true. Every n greater than 20, let's choose n is my 20. So this will be my 20. It is 21. It is 19 square. Is it even number? Yes, it's a even number. If I choose n is my odd 21, it is my 20, it is my 19. So is it even number? Yes, it is also the even number. Fine. So that means, okay, I can simply say if both the cases, if n is my even, then clearly say it is a even number. If n is my odd, then this number is my even number. Fine. This number is my even number. So that means whole is my even number. So that option is correct option. For every integer n, either fn is odd or fn is divisible by 4. That may or may not be true. It is divisible by 2, fine. But is it divisible by 4? We will see. If I choose n is my 20, 20, 21 and 19. So clearly say this number is my odd number and it is divisible by 5, yes. If I choose n is my 21, then it is my 22. This number is my 20 square. Fine. So is it divisible by 4? Yes, I can take it as a common. Is it divisible by 4? N is 20. How you can prove it in journal? Let me take one more. It's a 22 because it will be the 23 even number. Is 23 and it will be my 21. So clearly say this is not divisible by 2. This is only divisible by 2 but not divisible by 4. It is an even number. This number is my even number. Fine, because it's a multiply by 2. So it is a odd cancel. It is divisible by 4 cancel. You can easily see that because the second option, it is always the even. Fine. but it is even, that's the divisible by 2, but we are not sure about divisible by 4. Okay, the last case is for every odd number it is divisible by 64. So that's a simple, I can choose any odd number 2m plus 1. Then your fn will be 2m plus 1. It will be my 2m plus 2 and it will be my 2m. So if I taken as a 2 common from this, 2 common from this, that's a 4, 4 is to power 2, and the rest of the numbers are m plus 1, m. It is 2m plus 1. So that's my 16. But it said 64. How? You can see this, it is a whole square. Fine. Now you can see m and m plus 1 are the consecutive numbers. So whatever the m is odd or m is any number, this number is always be divisible by 2. Fine. If it is divisible by 2 raised to power 2, that's a 4. I can take again 4 as the common. That is the 64 is the right answer. So A, B and D are my right answer of the problem. Okay, we are in the given class of the 4 boys, 4 girls. Committee has been constituted with the president, vice president and a secretary. There is a 3 members. Let A denotes the number of the way, in such a way the committee has at least one boy, fine, and at least one girl. Okay, what is the B? B denotes the number of the way the number of the girls is greater than or equal to the number of the boys. I think that's a question related to the probability. Can you find the possible cases? At least one boy. I need a 3 possible cases. At least one. There are 2 cases. 2 boy, 1 girl, 1 boy, 2 girl, 3 boy, then 0 girl. But this is not possible because I need at least one case. So then what is the A? Can you find this? How many boys are there? 4 boys into 1 girl plus second pair 4C1, 4C2. So can you solve them? 4C3, 4C2 for 12 into 6, 4C4 is this, plus 4C4 into 6, 24 plus 24 is 48. Fine. Now look at the option which is multiple of the 48. Now clearly say 288, is it divisible by 48? Yes, so this option is the correct. 48 is not divisible by 144. You can see 144 is not divisible by 24. No, it is also divisible by 48. It is also divisible. So we have to think about another way. Fine, we will see 48. Now, so is it 288 divisible by 48? We will see 288. Let me do the calculator. 288 divided by 4. Yes, both are calculated. Now, how you can check about which of the following options? So how many possible cases? 3. So how many choices are there? 3 factorial. So I can multiply by 3 factorial. That is 48 into 6. So that is, this option is cancelled. This option is the correct option. Why multiply by 3 factorial? Because they are not given as a ordering. So that means how many possible choices? 3 factorial. Number of the girls are greater than of the number of the boys. So what are the possible cases? 3 girls, 0 boy, 2 girl, 1 boy, 1 girl, 2 boy. That is not possible. So I can, what is the right answer of this problem is? Let me clear this A portion. So that means the first option is 3 girls, 4C3, 4C0 plus 4C2, 4C1. 4C3 is my 4, 4C0 is 1, 4C6, 4C1 is 4. So that means 4 plus 24, that is 28. So let's see again how many possible cases? 3. So 28 into 6. So 12 12 and 16. So B option, this option is cancelled. You can also check whether 192 is divisible by 28 or not. It's a 9 2, 9 6, 14. So 7, 48. Again, you can see it is not divisible by 28. So that means the right options are A and B are the correct answers. Okay, for the positive integer m, again phi n divides for the all the cases. This is a similar problem as I told you. Phi n divides n for every positive integers. If I choose n is my 4, phi of 4 is my 2. Okay, he said divides for every. So I can choose a prime number. Then phi of 5 is 4 and 4 doesn't divides 5. Fine. Then phi of an minus 1, phi of an minus 1 and so on. In each case, it is phi of an minus 1. I can choose any pairs. I can choose n is my 2, a raised to power n minus 1. What is the phi of a raised to power n? A raised to power n 9 minus 1, 8. Phi of 8 is 4. You can see that 8 I can written as 2 raised to power k form. So that is a half of this number. Then 3 doesn't divides 4. That means A doesn't divides. A divides this number. Cancel. Is the GCD is 1? Yes. Fine. Now, and is it n? 4 divides then. Now, what is the definition of the phi m? So what is the meaning of this? What is the definition of this number? That means collection of all those x so that it will be less than of an minus 1 and the GCD of x and an minus 1 is 1. That's the definition according to this. So what is the possible values of the x? So x will be either the 1 because 1 comma this GCD 1, a square and up to the last number will be a of n minus 1 comma minus 1. Fine. Or you can simply say a of an minus 1. Fine. Now, what can you think about these numbers? So these numbers are satisfying these properties. Now clearly say, and the GCD is also 1. So how many multiples are there? You can see how many numbers of these cases. They are the n cases. So by the definition, it must divide about this phi of an minus 1. This divides an minus 1. Moreover, there is no role for the GCD of the an and 1. So whenever a and n have a GCD 1, then again they are satisfied because this is satisfied for all a and b, a and n. So the right answer is B and C are the correct options. Okay, now is December 2023. These are the part of the concurrence. Fine. As I told you this lecture already in my this PY questions. I will explain you again. Why I explain you? Because it's a recent year examinations. After this, I have to solve all these concurrencies part quickly. Fine. So let's do quickly. N is concurrent to 1 modulo 7. Student, make sure you have to listen this concurrent part very sharp mind because I told you very simplest way. 15 is not a prime number. I can break them into the 5 into 3. So n, when I taken as a 3, modulus of 4 modulus 3 is my 1. And n is concurrent to 1 modulo, no, 4 modulo 5. Fine, or minus 1 modulo 5. Fine. Now, how you can solve these three equations? Look at that. If I solve the another example, again, you have that more than two equations. How you can solve these three equations? How you can solve these three equations and so on. Fine. So I will tell you the again approach. Firstly, think about the any two equations. Look about the modulus 7 and 3. You have to multiply 7 by some number, 3 by some number so that it becomes a 1. Fine. Can you think about that? If I multiply this number by 1, this number by 2, then answer will be 1. So therefore, your new number will be modulus 7 into 3 is 21. And what will be that number is? That number is 7 into, because 7, what is the opposite of 7 is 1. So 7 into 1 plus, what is the multiple of this is minus 6 into, what is the opposite of 3 is 1. So 7 into 6 is my 1. Now look about these remaining equation, this number and this number. Fine. Again, you have the two parts, 5 and 21. Fine. Your target is to make this number as a 1. So can you make them 5 for 20 and it is minus 1, but it will be no, if I take this is my plus 1, 21, this number is my minus 1. So fine, this is satisfied. So therefore your new number will be some dash modulus of, multiply those, 5 into 21 is 105, and that number will be, what is the opposite of 5 is 1. So this number is minus 20 into 1. This is 21. What is the opposite of 21 is 4. 21 into 4. So this is 84 minus 20, that is 64. Now you can look at the option. N is concurrent to 1 modulus 3. Satisfied. N is concurrent to 1 modulo 35. How you can make the 35? 7 and 5. We will see. 21 is a 1 modulo 21. Satisfied. 1 modulo 5 is a 4 modulo 5. Now, for the second option, you need to find the modulo 35. That means first option, that means I have to solve these two options. Can you find the two numbers so that this will be 1? So 7, 5, 3 is 15, 7, 2 is 14. So then your N will be modulo 7 into 5, 35. So what is the opposite of 7 is 4. So 7 into 2 minus 14 into 4, that is minus 56. 5 into 3, opposite of 5 is 1, that is plus 15, that is my minus 41. So can you make this minus 41 is minus 6 modulo 35? Minus 6 modulo 35 will be my 29, but he said 1. So this option is cancelled. A and C are the right answer. Look at this another one. 2x is concurrent to 3a modulo 5. Fine. X is 4a, 4b modulo 5. Make sure this approach that I told you, make sure the coefficient of the x must be 1. So how you can make this coefficient as a 1? I can x multiply by 3. So then this number will be 3 to the 6. 6 concurrent 5 is 1. 3, 9, 4a modulo 5. And the second number will be x is 4b modulo 5. What is the shortcut tricks? As I told you in our last lecture again, find the GCD of this modulus. GCD of 5, 5. If it divides the difference of them, 4a minus 4b, then you will get as the unique solution. So what is the modulus of GCD of 5, 5 is 5. 5 divides 4a minus 4b. 5 doesn't divide, so it means 5 divides a minus b. A minus b is divisible by 5. Fine. Now, once you know a minus b is divisible by 5, that means a minus b is either 5, either 10, either 15, either 20. One equation is a plus b is equal to 24. If I solve them, what is the a? 29 over 2. But a and b are my positive numbers. So this case will be cancelled out. Fine. Look at the second case. Again, the 15 case will be cancelled out, because if it is taken as a 15, then it will be my 39. Fine. Now, if I taken this case as a 10, then what is the a plus b is 24. Then if you add them, a will be my 34, that's a 17. B will be my 7. A is my greater than b. Fine. So now look at the option. 17 is greater than 21. Not satisfied. This option cancel. 3 into b. 7, 3, 21. Is it 17 is greater than 14? Satisfied. A minus b is lies between Yes, you can see this is the a minus b. A minus b lies between 10 and 20. Now look at the third case. When a minus b is equal to 20, a plus b is equal to 24. If you add them, this will be my 22, b will be my 2. So now look at that 3b. 6 is greater than 22 is greater than 4, not satisfied. A and D are the right answers. Now again they are the modulus. So look at the first two numbers. Fine. So 5 into something plus 7 into something must be 1. So 5 3 is 15, 7 2 14. So your x will be concurrent to 7 into 5 is 35. So 5, the opposite of 5 will be 3. So 9, 15 into 5, 45, minus 14 into what is the opposite of 7 is 2. So that will be 45 minus 28, that's a 17. Then the last equation is 4 modulos 11. So your number is 35 into something plus 11 into something should be 1. Can you find the number? Now clearly say it is the multiples of the 11. So if I take 1, 31, 35, 11, not possible. If I taken as a 2, 70, 70 minus 69, but 69 is not possible. So it will be 6, it will be 19. Fine. So it will be my modulus of 35 into 11, 385. What is that number is? Look at that. 35 into 6. What is the opposite of the 35? 4. And it is 11 into 19. What is the opposite of 11 is 17. So what is the answer of this? If you solve them, it will be 2713. If you taken as a 385, it is my minus 18. Minus 18 is my 367. Fine. So 367 is not lies in this case. Now, which of the following intervals? So 367 is the first number. The other number will be 365 into k, where k is my positive integers. Fine. So now look at that. If k is equal to 1, then it will be 2, 9, 6, 15, 752. 752 is lies in the second component. If I taken k again, if I add them 385, then it will be 7, 13, 11. 11 lies in this case. Right answers are B and D are the correct answers. Find the least positive numbers. Again, I can solve for you. I can write the first any two equations. X is my 2 modulo 4. Fine. So it will be 3 into something, 4 into something should be 1. So 3 3 is a 9, 4 2 are 8 minus. Fine. So your x will be concurrent to 4 into 3 is 12. So 9, the opposite of 3 will be my 2. 9 into 2, 18. And opposite of 4 is 1. So minus 8, that is a 10. Fine. Then the third equation will be x is concurrent to 3 modulo 5. Clear? Then I can write a 12 and 5. Can you think about the two numbers? That must be the integer. So it will be 5 for 20. No. If I taken as a 1, 12. Can it 11? No. It's a 36. And it is a 7 5 is a 35. Fine. So therefore, your final answer will be x is modulo 12 into 5 is 60. Fine. So now, can you solve this answer? 12 into, what is the opposite of 12 is 3. So that means 12 into 3 is 36 into 3. It is a minus 35 into 10, 350. Then what will happen? If you solve them, it is 8108 minus 350. That is minus 340, 242. If you make them 242 as a 60, it is my minus 2. But we need as a positive integer. So that will be 58 is my right answer of this problem. Okay, look at this another one. Again, make sure the coefficient should be 1 and each numbers are my prime. And now they are the primes. So firstly, I can solve these two pairs. 3 into something, 5 into something should be 1. That's easy. 3 to the 6, 3 minus 1. So that will be x is congruent to modulo 5 into 3 is 15. So what is the solution of this? What is the opposite of 3 is this number. So 9, 6, 18 and 5 into 2, 10. That's a 8. Then I can solve these two equations. What will be the possible case? 2 into something plus 15 into something should be 1. Can you find the number? 7 to 14, 15 into 1. So your x will be modulo 30, 30. So what is the right answer of this? It's a 2. Opposite of 2 is 8. So minus 14 into 8 plus 15 into 5, 75. So it will be 8 for 32 minus plus 75. So it's a 7, 37 minus 37. Minus 37 modulo is my minus 7. Minus 7 will be my minus 7 modulo 30 will be my 23. So the right answer of this problem is 23 is my correct answer. Look at this one. Now you can see it is not a 1. So how you can make them 1? It is multiplied by 3. Then it will be 6 x 3 3 9. It will be my 4 modulo 5. It is not a prime number. Fine. I can break them into the 2 and 3. But you can see that it is whole divisible by 2. Fine. So then it will be my 2x is congruent to 1 mod 3. Then again I can make them as a 1. I can multiply by 2. 4 modulo 1 is 3 is 1. Multiply by 2. It is my modulo 3. And 7 is my prime number. How you can make them as a 1? I can multiply this number by 2. 3 to the 6. 6 will be my minus x. If I multiply by 2, it is 4 modulo 7. How you can make them as a positive is? It is my 3 modulo 7. Fine. Or you can see if I multiply this number by 4 3 12. No. 5 3 is 15. Yes. If I multiply this number by 5, then 15 modulo 7 is my 1. 10 is my 3. So x will be 3 modulo 7. Now again we can use the same approach. I can use the first two equations. 5 into something plus 3 into something is my 1. 3 to the 6, 5 into 1. So your equation will be x is modulo 15. So your solution will be 5 into 1. Opposite of 5 is 2. So that is minus of 10. 6 into 4, 24. That is 14. 14 I can written here. Or you can also written as a minus 1 if you want to make your calculation easier. Then I can solve these two equations. That is 7 into something. 15 into something should be 1. 7 into 2 into 1. So your final solution will be x is modulo 15 into 7 is 105. So that number will be minus 14. 7 opposite is minus 1. That is a plus 14. And 15 into 2, 30. That is my 42 is the right answer. So you can see 7 to is 14. Or if you want to write a 14, that is again no problem. That is a 7 into minus 2 into 14 plus 15 into 15 to 3. 3 is my 45. 5. So it will be my 59. Fine. Either you can solve by this manner or you can take it as a minus 1. Both the way the right answer of the problem is 59 is the correct answer. I can solve this question again for you. That's very easy because it's a prime number. If you remember my last lecture, that's Euler. We all know if it is a prime number, then it must be congruent to 1 modulo 13. provided x and 13 GCD is my 1. Fine. It is already given that it has a solution. Then you can find the relation between the n and phi of 13. Fine. Phi of 13 is my 2. You can find these pairs whose GCD should be 1. Fine. So I can give you this question as an exercise. You can try this question as a yourself and let me know your answer in the comment box. If you get the right answers, then I will assume that you have understood this lecture very well. So I will give you the answers, but you can tell me the answer in the comment box. I will tell you whether you are right or wrong. So I hope you can learn many shortcut tricks in this lecture too. I hope you can share, like and comment on my this video. Best of luck students. Happy learning.